Good morning, guys. Today's lesson is 2.13, linear and angular speed. Alright, so we've been dealing with linear speed, which is speed equals distance over time, or v equals s divided by t, where s is arc length, if you remember from a previous lesson. Alright, so that's the distance around an angle measure for a circle. Sorry, scratched something off my screen. Alright, so now we're going to talk angular speed. Alright, so when something's rotating around a circle, that's the speed and the angle. Alright, so we have this funky Greek symbol right here. This is called omega. And it's equal to theta divided by t. Alright, where t is time. Alright, so in the little box here we see we have angular speed, where omega in radians per unit time, theta is in radians because that's everything I'm using right now. Linear speed can look like v equals speed over time, velocity equals rate times theta over time, or velocity equals rate times omega. Alright, so there's three different formulas for speed, linear speed. Alright, so that's pretty much the main formulas for this section, so we use these ones to bounce back and forth and solve these problems. So example 1, suppose that point P is on a circle with a radius of 10 centimeters, and ray, OP, is rotating with an angular speed of pi over 18 radians per second. Alright, so important piece of information, we have the radius, ray OP, remember ray has a vertex and goes off in one direction. Alright, we'll call this ray OP. And it's rotating with an angular speed of pi over 18. Alright, so for our problem here, we're going to find the angle generated by P in 6 seconds. Alright, so basically what's happening is we have a ray. It's kind of like a clock hand, and it's rotating. Alright, so what it's doing is it's going around like that, and the speed of it is pi over 18. Okay, so we're finding the angle generated by P in 6 seconds. So angle is theta. Alright, so we want, our first formula is omega equals theta over t. Alright, so we don't know the angle. We know our angular speed right here, so this is going to be our omega. And this is our radius right there. So what we're going to get, let me erase this and change it. This is going to become pi over 18, is our omega, is equal to theta, which we don't know, divided by time, which is right there, so 6. So our unknown is theta, even though it looks like pi can be an unknown. So what we want to do is multiply the 6 across, cancels that out, multiply the 6 across. Alright, so we're going to have 6 pi over 18, which simplifies to pi over 3. And this, ladies and gentlemen, is our angle that we rotate through. So part B wants us to find the distance traveled by P along the circle in 6 seconds. So our distance traveled, alright, that's our arc length. Alright, so from a previous section, arc length is S is equal to R times theta. So looking at all of our givens around, I'm going to write it out. S is unknown because we want to find the arc length. R is the radius, which we saw in the very beginning, which is 10 centimeters. And our theta we just found to be pi over 3. So let's put it all together in a formula. Change color for this. So S is equal to pi over 3 times 10. So S is equal to 10 pi over 3. Alright, so that is our arc length that this object has rotated around. So, example 1, part C, we're going to find the linear speed of P in centimeters per second. Alright, so we know arc, so what we know we found theta, we found arc length, we know the radius. My daughter has joined us. What else do we know? And we know omega. So we know all these different things. So the formula I'm going to use from the top is velocity equals arc length over time. Oh, I forgot to add N5. We know time as well. Time, 6 seconds. So linear velocity is our arc length, which is 10 pi over 3 divided by our time of 6 seconds. So to evaluate this, can't divide by fractions, so we will do 10 pi over 3 times the reciprocal of 6, which is 1/6. Simplify where we can. We're going to get 10 pi times 1 will be 10 pi divided by 18. 6 times 3 gives me 18. Simplify again. So 2 is divisible. 10 is divisible by 2, and 18 is divisible by 2. So simplify, we get 5 pi over 9. That is our linear velocity. Okay, so we're basically just going from linear to angular speed. Because linears will travel in a straight line, where angular speed rotates around a circle. Alright, moving on. Example 2. A belt runs a pulley of radius 6 centimeters at 80 revolutions per minute. Okay, so we have our radius. It's good information. Radius is 6. We're going to find the angular speed of the puller in radians per second. Angular speed, key note there. So we're going to use omega equals theta over time. Alright. So this is my radius. This is actually our speed, but it's not in radians. So if we look at this, we got 80 revolutions per minute. Now remember, 1 revolution around a circle is 2 pi. So we're going to convert this to radians. So multiply by 2 pi, and then we get 160 pi revolutions per minute. Okay. And we also know that 1 minute is 60 seconds. Alright, because we went in radians per second. Okay, so we have to take is our 160 pi. This is our revolutions. And we want it in per second, so we'll divide by 60 seconds. So just a matter of simplifying things. Alright, so this simplifies to 8 pi over 3 revolutions per minute. So it's roughly, actually not per minute, we want per second. Sorry. That's ugly. Okay. So it's like 4 revolutions per second. I actually didn't need the formula at all, just kind of using what was given to us. Now part B, we're going to find that linear speed of the belt in centimeters per second. Okay, again, very important. So we use our unit of measure. So we know the radius is 6 centimeters. We know our omega, our angular speed, is 8 pi over 3. What we don't know is our linear speed. Okay, so we're going to use the formula that has radius and omega together. So velocity, linear velocity, or speed, is our radius times omega. So velocity, or linear speed is 6 centimeters times 8 pi over 3. Velocity is equal to 8 times 6 is 48 pi over 3, which simplifies to 16 pi. Okay, so our linear speed is 16 pi centimeters per second. Let me fix that. 16 pi centimeters per second. All right. And for our third and final example, so we have satellites traveling in a circular orbit 1,600 kilometers above the surface of the Earth. It takes 2 hours to make an orbit. The radius of the Earth is approximately 6,400 kilometers. So we know the radius of the Earth. We know the satellite is an additional 1,600 kilometers above the Earth. And we know it takes 2 hours to make a complete orbit. Alright, so our true radius from there to there, okay, from the Earth to the satellite, as you can see, is the 6,400 plus 1,600, which ends up being 8,000 kilometers. Alright, so that's our radius. So I'll put that outside. Radius is 8,000 kilometers. Alright, we know that one orbit, okay, is one rotation around a circle, so it's 2 pi. And this is our theta. Okay. That's all we need, I think, out of that information. So we're going to approximate the linear speed of the satellite in kilometers per second. So linear speed, velocity, equals arc length times time, or divided by time, I'm sorry. So we know time, which is 2 hours, but we don't know arc length. Okay, so we'll have to do our arc length formula. Arc length is our radius times theta. Alright, so radius 8,000 kilometers times our theta, which is 2 pi, 1 revolution. It's going to give us 16,000 pi. So that's our arc length. That's the distance around the Earth. So now substitute that in. 16,000 pi over 2 hours. So that's a nice easy simplification. So we get our linear velocity is 8,000 pi kilometers per hour. So our satellite is traveling pretty fast. You do 8,000 times 3.14. So this will be approximately 25,120 kilometers per hour. That's pretty fast. Moving pretty darn good. Part B, we're going to approximate the distance the satellite travels in 4.5 hours. Well, that's nice because we did that conversion above. So we are doing 25,120 kilometers per hour. We want to go see how far it goes in 4.5 hours. So just simple multiplication. Alright, and this will be approximately, let me get my calculator real fast, times 4.5, approximately 113,040 kilometers in 4.5 hours. There we go. Alright, ladies and gentlemen, this concludes the lesson. It's not too bad, just got to use a lot of formulas. I will post shortly what the assignment and the problems are going to be. Message me with questions if you have them, and have a great day.